In this lesson, we're going to talk about the universal set U, the intersection of two sets denoted by this little hump. The intersection means an and between two sets, and also the union between two sets, a fat U, and union means or. We're also going to talk about Venn diagrams. So first, let's suppose we have two sets. We have a set A that consists of the elements 1, 2, 3, 4, 5. We have a set B that contains the elements A, B, C, D, and 1. Then here I have labeled U. U is a universal set. It's any set that contains all of the sets that we're talking about in a problem. U can be any number of different sets. In this example, I just chose U to be 1, 2, 3, 4, 5, A, B, C, D, and 7. Now U contains everything in A, contains everything in B, and then I actually added an extra 7 just to demonstrate that you can have extra elements as long as it contains all of the elements that are in the other sets that we're talking about. I could have also called U the set of all integers and all letters, and it still would have been a universal set that applies to A and B that we have in this problem. Okay, so let's talk about how to draw these in a Venn diagram. First, I draw a box. A Venn diagram is just a depiction of sets using circles in a box. The box represents U, the universal set. So everything goes inside of the box, and I have two sets. I have set A, and I have another set that's set B, except I draw them so that the circles can overlap because they may have some elements that are in both A and B. And that's what I would put in the middle. So I look back at my sets and I say, oh, well, in these two, in A and B, I had a 1 in A and I also had a 1 in B. So the 1 is actually in both sets. So I put that in that overlapping area. That overlapping area right here, this is called the intersection because the 1 is in both A and it's in B. So the intersection is the overlapping area, and it includes all the elements that are in both A and B. So elements in both A and B. Okay, and then I go back to my sets and I look at A and I say, okay, well, what other elements did I have in A? I have to label these. I had 2, 3, 4, and 5. Well, 2, 3, 4, and 5 are not in B. They are in the universal set, but the universal set includes the whole circle of A. So I can just put my remaining elements, 2, 3, 4, 5, in the A circle. And then I have completed all of the elements in A. They're drawn where they should be. Then I look back at B and I say, what else did I have in B? Well, in B I had an A, B, C, D, and a 1. I already have the 1 drawn. So I put A, B, C, D inside the B circle. So everything in B is everything in this circle, including the 1 that we already have labeled in the overlap. Then I look back at at U, and I say, okay, well, what elements do I have left over that are not already drawn in my picture? Well, I have 1, 2, 3, 4, 5 already drawn. I have A, B, C, D already drawn, but then I have a 7. So I put a 7 in the outside to indicate that I have a 7 in the universal set that is not already drawn in one of these other two sets. Okay, so we talked about intersection. Then we have to talk about union. So we look at this graph and we say, well, the union is an or. In mathematics, an or means all of everything including the overlapping. If I say, including the overlapping area, if I say I want a cookie or a Coke, in real world, you assume that I only want one of the two. Well, actually, I could want both, but I'm just saying that I want a cookie or I want a Coke. I haven't decided which of the two I want. Well, in mathematics, what we mean by an or is it could be an A, or it could be in B, or it could be in both. So our union, this is our union. Our union means take all of everything in the two sets. So if I do A union B, that's how you write a union, A, U, B. That means everything in either of them. So I look at them and I say, okay, well, everything inside the two circles, including that overlapping area. Well, everything inside the two circles is everything in A and everything in B, and we just don't write any duplicates. So we write the one only once. We don't write it twice. So here I would write, I like to start just by listing off the elements in A, 1, 2, 3, 4, 5, and then I list off the elements in B, but when I get to that 1 at the end, I don't write 1 again because I've already written 1 in there, and then I just end my curly brace. So A union B is 1, 2, 3, 4, 5, A, B, C, D. And if we were to write out the intersection, A intersect B, well, we said that was the overlapping area. Let me point up there, that overlapping area. And so that is the set 1. And that's all there is to union and intersection.